8.5 is going to be about angles of elevation and depression, and we're still going to use those trigonomic ratios that we learned, sine, cosine, and tangent. So make sure you have your calculators handy and ready to go. So first thing is just knowing the definition, and that is that an angle of elevation is the angle formed by, this is crucial here, a horizontal line and an observer's line of sight to an object above the horizontal line. So elevation is above. And then your angle of depression, think down, is the angle formed by, again, a horizontal line and an observer's line of sight to an object below the horizontal line. So here they're giving you examples in this picture of an angle of elevation. Notice the horizontal line here, and then the angle formed here is the angle of elevation. And then your angle of depression, again, here's your horizontal line, and then here's your angle of depression. One thing to note is that horizontal lines are parallel, obviously. So anytime you have an angle of elevation, you know the angle of depression and vice versa because of your alternate interior angles theorem. So notice this forms that Z that we've talked a lot about. And so those angles would be congruent because lines are parallel, alternate interior angles are congruent. Okay, most of this lesson is going to be word problems and you setting up a picture that accurately represents the scenario that they are talking about. So in this one, it says the crossbar of a goalpost is 10 feet high. So if we draw a goalpost here, and that goalpost is 10 feet high, if a field goal attempt is made 25 yards from the base, we'll put feet here, might help us, that clears the goal by 1 foot. So we have another foot up here that football crosses there. So we have a total here of 11 feet in height. What is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? So that angle of elevation is going to be this right here. So that's that x degrees. Now, to be able to do this, we need to make sure that our measurements are in the same units. So I'm going to take this 25 and put it into feet. So remember, there's 3 feet in a yard. So that would make this 75 feet from the base of the goal. And then if you're sitting at angle X, if I'm sitting at this angle of elevation, the side across this 11 feet would represent my opposite side. The side right beside it or next to it, the 75, would represent my adjacent side. So opposite over adjacent is tangent. So the tangent of X would be 11 over 75. And then remember to figure out what the angle measure is. You on your calculator will do inverse tangent of that fraction. And they're asking us to do that to the nearest degree. And when you solve that, you should get 8 point something, but to the nearest degree is 8 degrees. Just as a reminder, I put this on here just to kind of bring this to your attention to remember when you're labeling your pictures, when you're setting these up, that your angles of elevation and depression have to go, they're formed with a horizontal line. So don't make the mistake of setting it up with a vertical line. All right, next example says a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression, so this time we're, up here somewhere in the air, and the angle of depression, so down here is a person somewhere, but that angle of depression, I need to make sure I get a horizontal line in there. That's going to be key, so I draw it correctly. The angle of depression to this person is 42 degrees, and the helicopter is 18 feet above the water. What is the horizontal distance from the rescuers to this person to the nearest foot? So this is what we're trying to find. This would be our x. So the nice thing is, again, if you know the angle of depression, then you know the angle of elevation. So we know that this is 42 degrees, and this is a right angle here. So if you're sitting at 42 degrees, opposite is my 18, and x is my adjacent. So opposite and adjacent is tangent. The tangent of 42 is equal to 18 over x. And remember, to solve this, you're first going to multiply by x on both sides. So I would have x times, hello, I got stuck here. Okay, x times, whoa, sorry, times the tangent of 42 is equal to 18. And then I'm going to divide by the tangent of 42. So if you can just get in the habit of memorizing, whenever your x sits on the bottom of your fraction, you're just going to basically swap these out. So tan 42 is going to go to the bottom like it is here, and your x will go to the top because those are going to cancel. And so when you do that on your calculator, 18 divided by the tangent of 42, you get out a decimal, but it's asking to the nearest foot, and to the nearest foot, that would be 20 feet. 20 feet. Okay, the next one says a lifeguard is watching a beach from a line of sight 6 feet above the ground. So I'm going to put that in right here, make that 6. She sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? So we're trying to figure out that distance there. And once again, if the angle of depression is 8 degrees, then that means this angle right here, the angle of elevation in this case, would be 8 degrees. So again, if I'm sitting at that 8 degrees, 6 is my opposite, x is my adjacent. I hope you're noticing a trend. Angle of elevation and depression is tangent for everyone. So the tangent of 8 would equal 6 over x. And so again, to solve this, you just are going to replace these. So on your calculator, you do 6 divided by the tangent of 8. And that's approximately, I'm going to round to the nearest whole, 43 feet. Okay, now we can also look at 2 different objects to be able to estimate the distance between those objects using angles of elevation and depression. So we're going to see how this works looking at this example here. So the problem says to estimate the height of a tree she wants removed, Mrs. Long sights the tree's top at a 70-degree angle of elevation. She then steps back 10 meters. So if you kind of pay attention to the picture here, you're seeing what's happening. 10 meters and sights the top at a 26-degree angle. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree to the nearest meter? Okay, so notice we have 2 different triangles here. So I'm going to, and some distances we don't know. There's 2 things we don't know. We don't know the distance between C and B here, and we don't know the distance between A and B here of this picture. So I'm going to first look at our small triangle, and I'm going to set up, if you're looking at that, we have the tangent of 70 is equal to x over y. And then I'm going to go ahead and solve that for x. So I would just multiply by y on both sides. So y times the tangent of 70. Okay? And now I'm going to look at the big triangle to deal with this second angle. So this big triangle, I have 26, I have this x, and then this side here would be y plus 10. Okay, so now I'm going to set up, oh, that's too big, another one here. So now we're going to use the tangent of 26, and that's going to be equal to the opposite side, which would be x, and the adjacent side would be y plus 10. Okay, and because we have 2 equations with x and y, what we're going to do is either substitution or elimination, which in this case, if it's easy to solve for one of the variables, which it's going to be for all of these, then I would do substitution. Okay, so I'm going to get this equation also equal to x, so I'm going to multiply both sides by y plus 10, and I'm going to put that in parentheses because it's a binomial. Okay, so now I have 2 equations that are both equal to x, and so what I'm going to do is now I'm going to take this, because all of this is equal to x, and I'm going to plug it in to x in this equation here. Okay, so what I'm going to have is this y plus 10 times the tangent of 26 is equal to this y times the tangent of 70. And you need to remember that tangent 70 is a number, tangent 26 is a number. So to solve, I need to distribute. So I would have y times the tangent of 26 plus 10 times the tangent of 26. And again, that's equal to y times the tangent of 70. Okay, now I'm going to get my y's. So all of this is together. That's squeezed together. I'm going to take that to the other side. That's representing a number. It'd be just like if I had it as 5y. To move 5y to the other side, I would subtract 5y. So I'm just subtracting y times the tangent of 26. Okay, so I'd be left with 10 times the tangent of 26 is equal to y times the tangent of 70, and then minus y times the tangent of 26. And so if you're looking at this, you should see that they have, over here, they have something in common. They both have a y. So I'm going to pull that y out. And when I pull that y out, I'm left with the tangent of 70 minus the tangent of 26. Again, those are representing numbers. We just don't have it written yet. And then that's equal to 10 times the tangent of 26. So to solve for y, I'm going to divide by this big number right here. And again, you're using a calculator, so if you're paying attention and being careful, you just plug all this into your calculator. Okay? So now this is gone. This thing cancels out, and you're just left with y. So on your calculator, you need to plug in 10 times, and it's not even a bad idea necessarily to maybe put this in parentheses too. And then you need to divide by, and make sure when you're doing this, when you divide, you have parentheses on the bottom denominator of that tan 70 minus tan 26. And if you do it right, so you guys need to be checking this on your calculator, because if you're not practicing this, you are going to struggle. If you did it right on your calculator, you should get out 21.6. Okay, now that's our y. So I'm going to go back up to my picture. My y represents the 21.6, but the question is how tall is the tree? Well, the tree is representing that x there. So I'm going to take my y and I'm going to plug it back in over here. I'm going to write, we're going to plug it in. So I'm going to take my x, so I have x equals, and instead of y, I'm going to do 21.6 times the tangent of 70. And you should get out 5.9. But here's what you need to remember. If you look back up at that picture, her eyesight was 1.7 meters above the ground. So we have to include that to figure out how tall the tree is. And it's asking to the nearest meter. So this is 7.6 to the nearest meter. That would be 8 meters. And that's our final answer. Now, this is going to seem hard and like a lot right now, but as you practice it, you'll get better at this. Okay, it's just going to take a little bit of practice. So here's the next one. This one we're going to draw the picture. It says 2 buildings are sited from atop a 200-meter skyscraper. So here's my skyscraper of 200 meters. Building A is sited at a 35-degree angle of depression. So before I even draw my angle of depression, I'm going to draw this horizontal line. So building A is sited, we'll say there. Call that building A. That's 35 degrees. So that means the angle of elevation would be 35 degrees. And then building B was sited at 36 degrees. So that angle of elevation is 36. Okay, so I could have written it up here. This was 35, and then this one was 36, but that's the same as the angle of elevation. The question is, how far apart are the two buildings to the nearest meter? So I'm going to let this represent the y, which is between the two buildings, and I'm going to let this be my x. So again, you're looking at two different triangles. I'm going to start with this triangle here. Okay, so that triangle there, here's my right angle. The tangent of 36 would be equal to my opposite, which is 200, over my adjacent, which is x. And on this one, you can solve that. You know, you just switch places here on your calculator. So 200 divided by tangent of 36 would be 275.3. So we can put that back in our picture, 275.3. Okay. Now I need to look at my big triangle. And my big triangle, I need to use this side here, which would be y plus 275.3. So I have the tangent of 35 is equal to 200 over y plus 275.3. Okay, and then I'm going to solve. So I'm going to multiply by y plus 275.3 on both sides. And when I do that on the right side, it just cancels out, and I'm left with 200. And then to solve this, I have to distribute this through because that tan 35 represents a number. So y times tan 35 plus 275.3 times tan 35. And that's equal to 200. And then I'm going to, all of this, remember, is a number. So to get it to the other side, I'm going to subtract. And I'm going to do that over there. And when I do that over there, it just looks like 200 minus, and I'm going to put this in parentheses so we don't forget. This is all together. I hope you guys can read that. I need to get a smaller pen. And then over here, so plus and minus, those would cancel. I'm left with y times the tangent of 35. And then my final step would be to divide by the tangent of 35. So on your calculators, you're going to put this whole entire thing in your calculator. 200 minus, and you need to make sure you get the parentheses right here before you do that, and then divided by tan 35. And if you do it right, you should be getting out y is 10.3. And the question said, how far apart are the two buildings to the nearest meter? So y represented the distance between the two buildings to the nearest meter. That would just be 10 meters. Okay, I do want to say just something else back to this. You're going to see ones like this on your homework. So make sure that you've written this down well. If you have a question about it, come and see me. But you need to practice this on your homework because that's going to come into play on your homework when you're solving and having to, you know, do substitution like you're doing here. Okay, your homework, you're only going to do 1 through 10 because you have to draw pictures and you have to solve. So the homework isn't long, but you do need to make sure you understand how to do this, how to set up your pictures, and then how to solve, especially if you're doing 2 angles of elevation or depression.